Welcome back, everyone. Thank you for waiting. We will now begin the panel discussion. Our moderator is Mr. Akihiro Nakao, Professor, Graduate School of Engineering, the University of Tokyo, and the National Committee Chairman of the Beyond 5G Promotion Consortium. Professor Nakao, over to you.
Thank you. Good afternoon, everyone. Quite sadly, we are approaching towards the end of this great event, but we are excited to welcome our distinguished panelists. And could you pull up my slides on the screen? So this distinguished expert panel would like to talk about efforts towards 6G around the world and expectations for collaborations. And we heard lots of talks already. And I first, introduce your organization and also your name quickly. And then we pass the microphone to everyone so that you can give us an update from each organization. And after that, we will have several questions. And if we have more time, so then we can take questions from the floor, maybe. Okay, so let's get started. I would like to welcome Professor Matti Latvaho from 6G Flagship, and also Abu Himanyu Gosain. You're going with Manu, but from Power Project, Northeastern University, and Professor Hyun Lee from 6G Forum, Dankook University, Korea. So please share your update very quickly, maybe 3 minutes maximum, so that we can only have one hour panel today. So please.
Should I start? Can I have my slides? Thank you. So in Finland perspective, we have these major components related to our 6G research arena. EU level 6G SNS, you heard presentation from Colin about that already, no need to explain it. 6G Bridge, which is Business Finland funded program for 6G, very nice set of projects ongoing already. Then of course 6G Flagship, which was started already 2018. And 2022 there was also 6G Finland established, which is more like a policy coalition, a forum where we want to find Finnish joint views on different 6G related policies. All of these entities have strong international collaboration component, either as one of their missions, like in 6G Finland, which doesn't have explicit funding as such. But in Flagship, 6G Bridge, 6G SNS, we have in all of these we have outside Europe collaboration component. It's one of the missions of 6G Flagship, and now the latest goal of 6G Bridge funding program, it's targeted to strategically important international coalition formings. And currently we have also EU-Japan project application open. So all of these are strongly supporting international collaborations, and I think we have to look international collaboration through real joint projects as well. It's important, of course, to have events like this, but we have to work through projects to get something concrete happening. Some of the 6G research drivers that are really haven't changed at all in 6G Flagship, but are let's say behind our technical research themes and topics. All of these are very important. Digital inclusion, it reflects to, for example, our research on 6G solutions for remote areas connectivity, which is extremely important. Democratization of services. Future ecosystems and business models. What can we do besides current MNO dominated mobile cellular deployments, like private 6G or local 6G as we call it, an area where we have collaborated with Professor Nakao for quite some time already. Privacy, security, trust issues, super important as mobile connectivity is part of the critical infrastructure, and users have to trust 100% to every aspect of service delivery. Service-driven network architectures, we have multiple different alternative access technologies already there, and 6G will bring new ones as well. So from the end user perspective, we don't really care how the data and services are delivered. We are interested in getting trustworthy delivery of services. So we have to rethink a little bit the overall system architecture in that sense. Local connectivity solutions for really super high-speed data rates, for example, utilizing sub-terahertz technologies as such. And these are enablers for metaverse type of sensational user experience. The role of AI and machine learning is, of course, important, as we all understand, and it will be a key part of anything where we are talking about 6G. Then the last but not least, regulation aspects related to 6G, but not only telecom-related regulations, but we have to understand enough of the regulation specifics related to different critical vertical application areas, like what does it mean from automotive systems or health systems or flight regulations, etc., etc. So we have to have solid understanding on those limitations. Then there was a request to say something about the most prominent explicit technologies that we could assume to have in 6G. I'm not going through these because there are quite a few of those, but these are actually most of the things that we are, or the critical things that we are working on at lower layers related to 6G RAN. And if I pick a few of these here, maybe a couple of these important things is, of course, the spectrum-related issues are very critical and important, and we have now some directions set by World Radio Conference until the next one. So spectrum sharing is aspects as FR3, very interesting research topic. Of course, we don't have tangible results yet, but we are all probably going to that direction. Another one really, really new and interesting is this joint communication and sensing, not only positioning type of sensing, but any type of sensing that we can use distributed wireless networks for, like seeing around the corner in urban areas and things like that. So this is roughly the kind of the picture that we are on daily basis dealing with. The last thing I want to emphasize, resilience. This actually, we have been having corridor discussions about that quite a bit during these days. So what does this resilience mean and bring to 6G? So you have bad experiences of terrible earthquakes, for example. There are always needs from national security perspectives. Defense forces, for example, they need really resilient solutions. Utilizing these dual use capabilities or possibilities of commercial technologies must be considered. But yet, these resilience issues are not, in our opinion, sufficiently covered in current major research programs globally. And this is something that we are thinking about to join forces a bit and maybe move forward in that. And in the future, you probably will hear more of that from us. Thank you.
Thank you. You are the fast runner, and I know how many white papers have you published from the 6G flagship?
I think so far we have published 13, and now there's a new one under preparation on generative AI. So anybody who is interested in participating in that work, please contact us and send us an email through our website that you are keen on participating that technical work on that. And actually the results, we hope that the results will be published and the white paper released at the 6G Symposium event, second week of April in Finnish Lapland that we are organizing. And there will be also nice participation from Japan side at that event, I've understood.
Okay, thank you. Let's move on to Manu.
Okay, good afternoon, everybody, and thank you for the introduction, Nakao-sensei. I'd like my slides up, please. Thank you. So yeah, just real quickly, the perspective that I want to share, that's a vantage point that I have personally being an academic, but also being fortunate enough to support federal agencies with the US Department of Defense, as well as with the NTIA, which is essentially the entity that manages DoD spectrum. Then also on the civilian and commercial side, the perspective of the US Federal Communications Commission on their 6G Technology Advisory Council. So with having sort of said that, and I promise that me and Marty did not collude on our slides, so these are all perspectives from the US, but as you'll see, things are pretty similar. So I'm just going to focus on the things that he didn't focus on, which is bullet number 2 around the open programmable virtualized network environment. So we definitely see the building blocks as we move from beyond 5G over to 6G, that the network is will continue to be more and more open. So open interfaces, open APIs, open data, and data is going to be extremely, extremely important. He or she who controls the data is going to control the new world order or the new paradigm. And I think for 6G, that's going to be even more important as you look from the radio interface, from the IQ sample level, all the way to the application, the transport layer. It's all going to be about data, and that's going to feed the engine for the future networks. Okay, so as I promised, this is me now switching hats and moving over to the US Department of Defense. This is a slide from the Future G Technology Office that sits under the DoD CTO, the Chief Technology Officer, and the DoD is already looking at ahead. So they are not using the moniker 6G because that's an industry term. The term that's being used is Future G. But again, the questions and the bullet points in terms of what we are focused on is around dynamic spectrum, which is obviously, as in the US, and again, I understand spectrum is a very regional thing, but in the US, the spectrum is being asked to vacate by the defense entities for use by commercial entities. So the idea is that dynamic spectrum management, to move tactical waveforms, tactical radars, tactical apparatus, there has to be very agile dynamic spectrum management that needs to be done there. The other idea is around software-defined radios, as well as hyperdimensional software-defined networks where optical technology becomes really important. The concept that the military uses in the US is something called JADC2, Joint All-Domain Command and Control, which essentially is a high-level orchestrator for controlling communication from a central command for mission-critical purposes. So this is the idea that 6G is very important for national security, and it's a critical technology, and it has been elevated to that level by the US Department of Defense. On the FCC side, so these are some of the spectrum considerations that Marty has also alluded to, and throughout the day we've been hearing about FR3. The point again I'll make, which I didn't hear yet, which is around NTN. So that's going to be the third dimension, and as you're moving from the XY to the Z-axis, you're now adding the potential where we need to understand how the channel's going to behave. If we are talking about a hybrid network that's going to have satellite relays, a mobile integrated access and backhaul, or direct to your handset satellite service that we are beginning to see, you're going to need to start talking about NTN in the standards body. But it comes as a double-edged sword, because right now, there are satellites that are being used for Earth exploration, fixed satellite service. All of that will need to be integrated back, and new spectrum sharing mechanisms will need to be developed in the 6G paradigm. So we need to be paying attention to that. And obviously, as we talk about terahertz, we're also going to run into some of the issues where agencies like NASA are controlling space communications and how that will have to be impacted. So that's important, and that's what we are working on. These are just some of the technology areas that we're looking at. I think this was covered a little bit by Marty, so I'm going to skip that in the interest of time. Okay, now, third hat, moving back to the academic world. Here I wanted to sort of talk about the digital twin. I think we heard from the operator presentations earlier today, a digital twin for all. For us, we've been building, and we've built an asset that is basically a network, open radio access network digital twin that we like to call Coliseum. It was developed initially by DARPA, which is the US DoD funding agency, similar to NICT here. But the idea here is that you have a channel network emulation system that allows you to accelerate and address some of the key concepts that we have seen are going to be the basic foundation of 6G. So just kind of a vision board for us to think through, and this sort of ties into international cooperation and collaboration, which is to sort of do the testing internally in your own research labs, whether at federal funding agencies or in industry or in academia, and you essentially are able to wrap your entire experiment in a software package, and then port that software package from your local research infrastructure or testbed over to a larger scale one, over to a global one, and you're able to do this over multiple testbeds for cross-platform validation. So what do you need? You need the design, which is your experiment. The biggest part is you're going to need data. And then you need the validation that has to happen across multiple regions, not necessarily for validation of your own idea, but for the extrapolation of how your algorithm, your optimization is done, but also for validation, which today in the standards world is left up to the interpretation of the person submitting the idea or the algorithm. So I think that's going to be important. We need to keep continuing the collaboration and sort of foster things for the future. Thank you. With that, I'll yield my time.
Thank you. So you're wearing too many hats. Maybe you can play 3 panelists at the same time, maybe. Professor Lee.
Okay, thank you for kind invitation, Nakao-san. I'm from university, but I'm serving as the vice chair of 60 Forum, responsible for international collaboration. Okay, this brief snapshot of 5G in Korea. In terms of subscriber, now the 5G subscriber has around 40% of total mobile subscriber. But I think in 3G, 3G and 3G and 4G, they include roughly more than 20 million IoT type device. So if we focus on the human subscription, then I think 5G will be around almost half of the human subscriber. Regarding the mobile traffic, in 5G user consumes monthly roughly 27 gigabyte, while the 4G LTE user use just around 7 gigabyte. So roughly 4 times more traffic consumed by 5G. So in average, the around 17 gigabyte per person in Korea. So I was surprised that in India, the monthly average mobile consumption is 20 gigabyte, higher than Korea. Okay, it's interesting. And regarding spectrum, there are interesting news. As you may know that in Korea, the 3 mobile operators had 3.5 gigahertz spectrum as well as 28 gigahertz before, but the 28 gigahertz deployment less than expectation, so they returned their license to government. But the government tried to issue new license for 28 gigahertz. So 2 days ago, there was auction, and finally we got a new mobile operator called Stage X. So they will use 800 megahertz bandwidth from 26.5 to 27.3. But they don't have incumbent network, so the 700 gigahertz will be used for anchor. That means the control plane operation. And interesting. So for this new operator, the government requirement is loosened. So before, for previous mobile operator was requested to deploy 15,000 base stations per 3 years, but the new requirement is just 6,000 base stations, so roughly less than half. So the new mobile operator will have less burden for deployment. However, in terms of license fee, the government set the minimum fee of like 56 million US dollar for 5 years. But there was tough auction among 3. So the final license fee rose up to $350 million. So it's very big money was the result. So we are worried about the financial burden for new mobile operator. But they said, the Stage X said that they will focus on special environment, not in in general environment, like a B2B or some fixed scenario. So we will see their success. Yeah, regarding a big program for 6G R&D, yesterday the Korean officer already shared the technical areas. So I will not repeat on that. Basically, we have three phase. So we already have the 6G core technology research program ongoing, start from 2022. So it will go roughly 4.5 years, and around 150 billion US dollar will be invested for 4.5 years. And regarding the 6G system technology research that just started from this year, so it will go until 2028 for 5 years, and total 250 billion US dollar will be invested for this system research. And in addition, now we are the Industry Academia Consortium proposed a new program for LEO satellite R&D research program. So now the government is on the evaluation. Actually, in Korean system, we have two-phase evaluation. The first phase is for technology feasibility. The second phase for business feasibility. So we already passed the technology feasibility of the LEO satellite research. And we are waiting for the result of the business feasibility. If that is approved, then we will start this program from next year until 2032. So it will have 31. So 7 years, and total around 400 billion US dollar will be invested. So if three program goes well, we are ready for the successful 6G commercial service around year 2030. My last slide is the global collaboration. Maybe this is the topic of this panel. We are doing many collaboration, but basically in 3 groups. The upper side shows the multilateral collaboration. So we are doing annual event jointly. Korea, Japan, China, Europe, North America, and India and Brazil. And we have also on the left bottom side, we have several bilateral collaboration with UK, Turkey, and Malaysia, Indonesia, and Taiwan, something like that. In the right bottom side, we have a collaboration with the industry forum like 5G-AA and 5G-ACIA. The collaboration doesn't have just information sharing, so we had several joint R&D as well. For example, with Japan, China, EU, USA, we had several joint R&D program ongoing or finished. And I hope to extend that kind of joint R&D more. Okay, this is a very brief snapshot of the 5G and 6G status in Korea. Thank you.
Thank you. I'm always impressed at how fast that Korea is moving in terms of 5G deployment and also market penetration. Thank you very much. Now, can you pull up my slide? So I'd like to ask you, I just noticed that, 3 of us and 1/3 of Manu are from universities. So, you are crazy researchers. Crazy is a compliment to you, maybe. So I'd like to borrow your wisdom to answer these questions that I prepared. So I have to give you a little bit of background of this question. What are the most promising and beneficial 6G technology use cases, in your opinion, and how can we promote them? So in the past days, we listened to lots of interesting talks and invite international partners. And especially, we saw many technologies put on the white papers. But now, so yesterday, Magnus from Ericsson was mentioning that this is end of the beginning. And we have to prepare for standardization in several years now. And we are running out of time. And what are the priorities? So this is my basic question. And so today, David from Nexi talked about prioritized list of technologies. So they listed up 10 of them, and they have 6 audacious goals. And I'm very interested in what's the process to come up with that, because we have to agree on those top 10, for example. Well, that's the story of Nexi, but we have to, in a standardization arena, we have to agree on, priorities of the technologies. And I'd like to ask your opinion about those. So we hear today that we have like FR3, centimeter wave spectrum band, sub-terahertz, NTN, spectrum sharing, all these technology. I just heard from you, but in your opinion, what are the promising technology you think that you should standardize, and why do you think so? Because technology. We talk about technology all the time, but I think it should be backed up by values that we look for in future. So I think I want to ask you which area we should focus on for standardization or pre-standardization, or why, what value that you look for in that technology. Okay, now you're unleashed, and who goes first?
Okay, I'll build off of what you're saying, right? So you're coming at it again. I know I'm supposed to wear my academic hat and sort of really belabor technology development, but I want to sort of look at it from the other side, which is the use case side, because that's where I think, and Mr. Pathak also talked about, use cases is going to be very important, and how 5G has not fulfilled MMTC and URLLC. So I think for us, it's going to be very important to tie that piece in. And with that, we know that the SA1 3GPP first workshop is going to be in May, where we are going to hear from some of the people in the room, but they are going to present their 60 use case vision. So the idea is going to be backing up from where the use cases are seen. You have to sort of fit where the technology is going to move from. But that's just the alignment of where technology has to go, because if technologists are left to their own devices, we're just going to continue to build and build, and you shall see if they'll adopt it. But I think that's not probably a good use of where we want to go. Purely from technology perspective, again, from a system level idea, I feel that we really have to continue to see what's happening in ORAN and Open RAN, because that is primarily the first entry point for AI and ML in the network. We are talking about AI-defined native air interface, but the idea or the promise is going to be on the service management and orchestration. And how are you able to connect all these disparate networks, whether it be private enterprise deployments, whether it be the commercial deployments, or it be the local deployments for rural areas. So I think we have to continue to see where that's going to take us. Obviously, in standardizations, RAN is going to be very important, so we have to see what we're going to do, if it's going to be a continuation of OFDM, or are we going to start to adopt or look at other key technologies. And last but not the least, optical. So optical is going to be very important. I know that's usually handled by other standards, but really looking at the promising work that's happened with the open ROADM concept, the reconfigurable optical add-drop multiplexers, that has really helped in achieving large-scale backhaul. It's helped in achieving large-scale efficiencies, as well as programmability down at the physical layer, where we can switch data in the physical light domain. So I'll just stop there.
Okay. Before going to Manu, I'd like to ask you, so you listed up the ORAN, AI, ML integration, and also you talked about optical. So what are the values, that those technologies should be able to bring us?
So efficiency, right? We saw some of the, again, reference the today's work that we saw from the operator community, where there was talk about energy efficiency, traffic steering, the idea that you are now, the other element of all of this around 6G, we're talking about society, we also have to talk about the environment and the climate, right? So we can't just ignore the fact that the RAN sites, which are really a big hog of energy, electricity, but also on the other side, pollution, they need to be optimized. So the promise there is, first of all, you have the ability to disaggregate the network, and you have the idea of having more intelligence built back into the cloud and the edge rather than the air interface. So the idea is around efficiency, around sustainability. On the optical domain, you're going to see a large amount of aggregation, because as you have distributed clouds, those clouds are going to need to be connected with the, to process large amounts of IQ data, for example, that's going to flow through the network. So that needs to be in lockstep with where the system architecture is going to be. And I think the value proposition from my perspective is efficiency. And ideally, if you look at it from a business perspective, revenue and costs, right? Revenue minus costs equal profit. Simplifying or oversimplifying the statement, but if you are able to reduce the costs, you may have a chance, because right now we haven't proven with 5G that we can increase the revenue.
Okay. So I must rephrase that, can I rephrase that, your statement that your first priority is open interface and AI. Maybe second one is optical. Okay? Manu. Oh, sorry, Patti.
I don't know what hat I'm wearing, but we are crazy researchers, we can say whatever we want, right? So I think to answer to this really broad question, we have to define first KPIs and KVIs. Without having that clearly in our minds, it's impossible to answer to this question. But if the KPI is to increase capacity, greatly increasing the data rates, we should remember very simple laws of physics, that how can we improve capacity? We can have more spectrum. The question is, where do we get it? But anyways, more spectrum, more efficient use of spectrum, existing spectrum even, by developing all kinds of physical layer solutions, multi-antenna this, multi-antenna that. And the third one, which seems to be forgotten after 4G, densification. By placing base stations much more dense grids, we can have much higher spatial capacity. And we had this old concept of femtocellular technologies, and it's no longer discussed at all. And from operator perspective, that would be a fantastic way to save a lot of energy bills, because consumers are paying the electricity bill, and everybody should be happy. But for some reasons, operators are not really promoting it that much. So that's somehow forgotten. Maybe it should be reconsidered. I don't know. Then there are other issues. If the KPI is energy efficiency, then we cannot at the same time be dreaming about 10 or 100 times higher capacity if we want to push energy to fraction of what it's today. It's simply impossible unless something really greatly new is invented. I'm not saying that it's not totally impossible, but not in a foreseen standardization timeframe. Looks a little bit like that. If the KPI is to improve resilience of society, then we have to start to look at totally different things, more robust technologies, depending on the exact scenario. We have to start to think about how to provide services in really remote areas, isolated totally, very limited or no backhaul connection, for example. What other solutions there? There are alternatives to do that. And then if the KPI is really some imaginary future application coming from whatever metaverse thinking, then we have to really like crazy push the data rates to the limits of what can be achieved by all different means. Then we probably would be interested in looking at sub-terahertz, terahertz technologies, optical wireless technologies, you name it, anything possible. But so I would say that there's no clear candidate, favorite thing. But I think that we have to do as much as we can to improve capacity. Primarily, we want to have much higher coverage because we will depend on digital services more and more. So how do we improve coverage in terrestrial technologies? Of course, satellite is satellite, but if you look at terrestrial. And then I had third one, which I already somehow forgot, but maybe I can come back to that later.
Okay, Matti. So it's a very smart way to answer this question. You know, what are the, I mean, most prioritized KPI that you're looking for? Coverage, you think?
Coverage, energy efficiency, capacity, reliability. They are pulling to different directions.
Yeah.
I might even want to say that they are orthogonal requirements, but somehow we have to move in that jungle and try to find the best bad compromise.
Okay. Okay. All right. Four of them. Okay. Professor Lee.
Okay, I may touch the second bullet point on standardization because since I attend a regularly process 3PP, there's some issues in standard. For example, some people said that we should have a single global standard for 6G, but I think we don't need to worry about the single standard because until 3G we had the multiple standard, but since 4G we effectively have single standard, so we don't need to worry about the single standard issue. However, we need to consider the efficiency of the standardization. My colleague from MediaTek told me that only around 20-30% of the features, standardization features, are actually implemented and used. So we are we did the standard work inefficiently. So maybe so for 6G we should be focusing on the actual work item. So that is one thing. And regarding the schedule, now we are doing Release 19, and if the work goes smoothly, then the 6G standard can be part of the Release 21. And actually, implementation may be done by Release 22. So I think from schedule-wise, I'm confident. However, when I recollect the history of 5G, we had some, I think I can say we had some mistake. So we hurry up the 5G standard. So initial commercialization based on non-standalone mode. Now we are busy to migrate to standalone mode. So we don't need to repeat that kind of experience. Yeah, that is my view on standard. Regarding technology priority, I think many people said already, so I will skip that one.
Okay, so do you want to say more additional aspect, like Manu, you mentioned about spectrum sharing aspect. Do you want to say anything about that?
So on spectrum sharing again, right, like that's almost a foregone conclusion. When you look at 7 to 15 and you really look exhaustively of who's already out there, there is a bunch of incumbents, a different bunch of services, and globally it may be a little bit different, but it is pointing in that direction that you are going to need to think about native sharing regime. So how do you understand who's out there? Do you do environment sensing? Do you do incumbent informing? How does standardization play a role into that? Should we be using bespoke mechanisms? In the US, we are using the CBRS, the Citizen Broadband Radio Service, where we are doing spectrum sharing with military radars, and it is a tiered access system. So I think, at some point, exclusive use, as much as the mobile network operators in the room may not like that, might not be a native approach that we may follow. One just point I wanted to build on top is, I think, also to come back to your point, Aki, was, which technology? And, as correctly pointed out, it's never about the exhaustiveness of standards. It's about the implementation. So 20 to 30% is what's implemented, right? Like right now, what we're looking at from the Department of Defense side, 5G does have technology like Sidelink, but Sidelink is not implemented. It would be hugely, immensely popular, and it would be a huge need to do more too, infrastructure less. But that's not something that, you have availability of chipsets or anything like that. So in that piece, you're going to see it, but I still think the AI ML piece is going to be important. The compute fabric continues to accelerate. You have different varieties and variants. You're seeing introduction of GPUs. You're seeing multiple implementation on platforms like x86 ARM. So there's going to need to be a more consolidation of the communication, the compute, and the data paradigm. And data, I also want to emphasize. We need to have some standardization around data. So if people in 3GPP want to pick that topic up, that'd be great too.
One thing that is a little bit different from these questions, but I would like to point it out anyways, is that when we look at now the developments that are taking place in Wi-Fi 7, Wi-Fi 8 domain, lots of those are exactly similar to what we are talking about in the context of 5G, even 6G. So it would be very interesting to see if 6G is going to develop towards, let's say, more like a local private networks direction primarily or mainly, and I mean revolutionary ideas and evolutionary going in the lines that 5G Advanced is showing us already for macrocellular deployments. So is there need for these highly efficient local 6G solutions, because Wi-Fi is taking huge steps exactly the same direction? It will be very interesting to follow that, and maybe we who are looking at primarily 6G should also keep our eye on Wi-Fi 8 as well.
So far, I think you have heard of talks by Japanese telecommunication companies today, and they mostly talk about AI, ML integration, and also optical communication, and of course, millimeter wave and all these new, the centimeter and also those high band spectrum, right? But I wonder, are we aligned internationally on this view? Because I heard of talk about AI integration many times today, and I agree with you, Manu, that the AI ML integration should be one of the most interesting topic. But so other things are internationally coordinated, because so we run an international committee of the Beyond 5G Promotion Consortium. First thought about what would be the technology that needs the international coordination. And we picked up several areas. That was year 2020, so we were not imaginative enough at that time, right? So then we picked up NTN. You heard of Toyoshima-san from NICT, and NTN, and also high frequency band from Dr. Hosako-san. Yeah. So these two working groups were moving quite fast and collected lots of interest from international partners also. So we were quite successful. But are there any other items that we should develop internationally for the coordination? Well, spectrum sharing is one. It was mentioned by you and Manu, AI, and also local 6G that you mentioned just now. The local connectivity may be one. Centimeter wave is one. Maybe you can mention that. Are we able to identify any technology that we should have a coordination towards standardization? We agree on doing that standardization last year, in December. 3GPP already started.
Well, one corner is missing. So we have touched all other new corners. I mean, these 6 corners of 6G use cases, combined communication and sensing.
Oh, yes.
So that's missing, and also from as a researcher, that's really interesting, and because that's really a novel radio-related technological part in that. So that's definitely one.
Okay.
Yeah, I'll just add, if you're looking at sub-terahertz, and again, the terahertz researchers in the room can chime in, but natively that technology allows you to do sensing and communication on the same channel because of the way the waves are behaving, right? So you have impulses, you have the idea to do precise, positioning and sensing and communication on the same side. Now, on the terahertz side, I still do want to say, and I think the operators would agree with me, the workhorse for 6G in terms of the generalized coverage capacity issue, the workhorse will still remain mid-band. Terahertz would probably be supplementary technologies, NTN would be supplementary in terms of maybe increasing indoor, and that's another important thing that we need to study. I know 3GPP is also looking at it, indoor to outdoor, outdoor to indoor. How does the channel behave when you move from one environment to the other? How are surfaces going to affect the channel? So basic fundamental research questions need to be answered as you're looking at moving in the outdoor to indoor and indoor to outdoor kind of a perspective. But again, I come back to the bigger point, which is you have to sort of drive it from, as Marty was saying, from what are you trying to achieve and what is going to be different. And that's why I think it's really, really smart that all the different consortia, alliances are including a societal impact story into the early requirements and definition of 6G.
One of the problems still is, in my opinion, that we are trying to sell soap to everybody. So exactly mobile broadband, and but the future, in our view, researchers' view, this is not my personal only, but many people share it, is that in the future we will have different capabilities in different parts of the networks, and operators should also understand this better, and they really should support that kind of development. If there are third parties who are interested in making investments and improving the capabilities of networks with different services offered to any operator customers, as we are talking in local 6G contracts, let them do so. Let them build new capabilities. Let them really make really new big steps for offering totally new types of services. We don't know what the services will be, but we will not be selling soap in 6G era.
Okay, Professor Lee.
Okay, regarding the potential collaboration area, I may say something details regarding NTN. Currently, the only LEO system is provided by big countries like Starlink or OneWeb, or in future maybe in China. But they need at least a few hundred satellites, and every 3 to 5 years they launch again. So it is burden for single countries. But I know that many countries are interested in satellite, LEO satellite, Korea, Japan, Taiwan, Singapore, something like that. So at least for this business area, we need collaborate as well as in standard. The current LEO system is not standard-based, but I think I believe that in future LEO system should be standardized to have some economy of scale.
Okay, thank you. So I think this panel is recorded. Maybe a few years later we can review this video so that our prediction is correct or not. Right. Okay. So, well, but I just want to point out that now we have to exercise our maybe power of prediction, maybe because we are, the standardization is just around the corner. Maybe we start thinking about, what to prioritize among all these things that we put on the white paper. I mean, just, we don't have an answer maybe today, but I think we need to work on internationally so that we can, what to internationally coordinate.
I think we will be much wiser when the KPIs are defined.
Yeah.
We don't know them yet exactly. We have some guesses of those, but I would take, let's say, maybe dual track. Mm-hmm. So one track is to try to look at macrocellular deployment, how to improve what we have achieved with 5G so far. What does it take? What does it mean? Obviously, operators cannot increase the number of base station sites for many reasons. Mm-hmm. They want to have higher capacity at lower energy consumption. Really, really, really ambitious targets. Mm-hmm. Then the other direction is that what we should look at a little bit separately, how can we really make this metaverse type of world happening at some point in the future? And what does it take? What does it mean? What type of technological solutions it means, and how to build 6G in such a way that it leaves the door open for that development. That should not come first, in my opinion. We should improve reliability and coverage more than bringing metaverse services to everybody as a first step. So I think the prioritization needs to be done.
Yeah, I think it's a good point. Maybe we should, we should think about how to solve the current problem, but at the same time, maybe we can seek new value that may be enabled by the new technologies. Okay, so I know that we are talkative, so we are running out of time. So maybe let's move on to the next one, next question. So this question, I like to, ask you for your advice. What value are you looking for in international co-development of 6G? Because, the easy answer is that, we already talked about in the first question. So the pre-standardization, we have to have some sort of a coordination efficiently proceed on the standardization. But what else? Or if you want to talk about standardization, it's okay. But what value that you're seeking in international? What brought you here?
I've been in mobile communications research for 30 years already. I've seen quite a bit things happening. And what is really great and extremely positive during 6G development is that there are different coalitions, different parts of the world, which are actively discussing and exchanging information. I think we have so huge challenges globally currently that we have to work more together. No one should try to solve those alone, and it's even impossible in practice to solve those alone. So that is already extremely positive, and we have to be proud of where we are now. But we have to also start to think about, could we do something more? What is the next target? And during these corridor discussions, we have been talking about that already. That what kind of bits and pieces might be missing in international collaboration, and can we do something together to make those things and important, valuable targets happening as much as we can help in that. But standardization issue, I think it is a process of itself, very complicated, existing structures, monster structures, and I don't want to go to that direction at all in this discussion, but that will happen. Standard will happen, for sure. We have seen it in past.
So I just want to go back a little bit, right? So the global pandemic really caused us to break a pipeline, especially around your point around recruiting young talents. Workforce development was significantly impacted when, because the transition, the migration of ideas and people was stopped for about 2.5, 3 years. We've done a lot of work now, and especially, credit goes to the multiple coalitions and alliances that have been set up with a goal to look at 6G, and they are looking at trying to improve the workforce development aspect of it, whether it be from fundamental research, whether it be the cross-pollination of ideas, the good researchers, the strong researchers moving across borders. So that's going to be important. We need to continue that. We need to foster that. In terms of where we're seeing the value for international cooperation, it isn't a zero-sum game, right? 1 + 1 should be greater than 2. So the idea is the good work that's happening. So people that are doing really good work in materials should be collaborating with the folks who are good at the network layer, right? The beauty of our communication model is it's a vertical and a horizontal layer. So you have the ability to sort of cross-pollinate and share ideas, but I think the one thing that still is missing, and I think that's what would be a call to action, so to speak, for all of us here, would be to try to come and agree on a very brief narrative idea of what is it that we want, what's a low-hanging fruit, or not a low-hanging fruit, but an extremely critical piece that's going to be important at a global level, but also has some local national implications on it.
Well, it's true. So that's the very reason why I brought up this first question, what would be the, low-hanging fruit. And it's good that you pointed out this global pandemic that happened a few years ago. I think what you're saying is that we are looking for value for, internationally valid value. Everybody share this because we have to maintain our life. and maybe, yeah, start from there. Maybe we have to work on that.
One more thing related to this international, let's say, exchange of ideas and experiences is that we are, in the end of the day, we are developing applications and services for totally different societies. So to increase the knowledge of the societal needs in different parts of the world, I think we don't know that and understand that well enough, I mean, in the broad sense. And maybe that's an area where we could still improve quite a lot. And also linking that to critical verticals in different parts of the world, what are their needs and how we can hear their needs more than so far.
Okay, good. Professor Lee?
Okay, regarding, when I recollect my experience with global collaboration, especially for joint R&D, many of them focused on the just core technology research. But if possible, in 6G, I'd like to extend it to some kind of joint trial, the joint activity for POC type activity. So that will reduce the time for real commercialization. So that is my experience and hope.
You want to add?
No, yeah, just wanted to add that spirit is also being looked at the NATO level. So if you're looking at the NATO level, there is a strong alignment between the different ministries of defense, the different defense departments on, and as of today in the NATO environment, there is no, and I'm just using a NATO term called a STANAG, a standardized agreement on 5G. That does not exist. However, that is work that is being led in the NATO standard office within the IST group, and from there the idea is IST 226 is going to start to look and try to bring and reach or develop a standards agreement that would be available on the NATO side as well. So that's where kind of a wide area or a global trial would also be in strong alignment, but I do support this idea. And for me, it's platform validation, cross-platform validation, right? The idea is the scenarios that you are implementing are different, right? So natural disasters are more prone in Japan. Yeah. Coverage and cost of providing low-cost user equipment is important in India. All of that has to be considered, and where those technologies fit. And when you look at it from a different perspective or somebody else's perspective, you really do start to value what you want to do. And that's the biggest learning for us.
Good. So driven by value for human beings, societal need, and POC, joint R&D, and platform validation. Good. Anything else that you want to add? Because we are running out of time. Do you see value of this conference?
Yeah, and I think, again, right, like if there is a call to action, you have government here, obviously all this is going to take funding. Yeah. So, we want to make sure that the funding pipeline continues and there is support from the political level, from the government level, from the agencies that are entrusted to sort of continue this development, because the time is now, as we say, standardization is around the corner, technology needs to be developed, the requirements need to be developed, and the idea here is that funding has to be continued. So in the US side, there seems to be a agreement both between the Republicans and the Democrats. That is something that even though they can't agree on anything else, the technology division has been pushed. There is significant amount of funding that's coming down the pipeline in the National Defense Authorization Act, but also in the broader US Congress, where there's been significant funding. And the US will carry its own weight for sure, but I think globally we do need to step up and provide more support to local institutions.
Thank you, Manu.
From Finnish perspective, our current government has made a decision to significantly increase RDI investments, and given the size of our nation, very small population, we desperately need international collaboration. Otherwise, there's no way we can consume the increased budgets as easily. So we really do rely on international collaboration. We do rely on having international staffs visiting us, recruited by us. So it's part of our daily life. Currently, out of the flagship big staff, we have maybe 2/3 are originally from outside Finland. So that is really international environment. And in order to have international collaboration, you have to start from your own corners. So you have to be international yourself before you can collaborate internationally. That's my personal opinion.
Good. So let's talk to our own government. So we heard a lot of useful ideas. So Manu said that bring ideas, wisdoms, so that we can make 1 + 1 more than 2, and also maybe we can do POC, and that's very important. We seek for the shared value across countries. So that's the reason why we should do collaboration. Okay, so we run out of time, so we have to ask for the final words. Take turns, and maybe you can give us, what you learned from this conference or panel. Whatever, expectation to Japan. Your opinion about international collaboration. Anything is fine. I'm happy to serve as moderator, but at the same time, sometimes I feel unhappy that I can't speak a lot as a moderator. Maybe you can speak for me.
Very, very briefly. So thank you, Aki, for inviting us here, first of all, and it has been a great pleasure. Unfortunately, inspired by this terrible earthquake on the New Year's Day, this resilience of mobile technologies has really been given faces, and the needs for that are now very clear. And that is an issue we have been discussing quite a bit outside the sessions, and hopefully in that domain you will hear of us in the future as well. And we aim at doing something meaningful in that area. So thank you, Aki, also for leading those corridor discussions.
Yes, thank you. We have to do more.
Yeah, I'll echo that, right? So the idea is, final words are we have to build the networks of the future. I think I'm impressed by the momentum that the Japanese government, the industry partners, as well as the global ecosystem that's here brings, the energy that we need to continue with, the momentum that we need to move forward with. I think I'm also excited to see the showcase next year in Kansai in 2025, and a lot of those details were shared. So as they start to mature, that probably will be, frankly speaking, one of the first forums, and I think Japan leads the way to showcase the digital society of the future. So what of those technology advancements are going to be, I think the world's going to be watching. So we're excited for the next year.
Thank you. Personally.
Okay, first of all, thank you for giving me this opportunity. Since the technology is getting more and more complex, so now a single company or a single country cannot do all the things. So anyway, we need to collaborate. But unfortunately, in recent few years, some kind of international relations was distorted. One by the COVID pandemic, the other one by G2 country tension, raising their protectionism. But if things are going well, we can recover. We return to the good collaboration, role division of each function. For example, in Korea, Japan, Finland, they have their own technology area, strong area. So if we combine them, it's more effective and efficient. So I hope we can return to the good years before. Thank you.
Thank you. So from me, thank you all the panelists, and also thank you all the attendees. As a representative of the International Committee of the Beyond 5G Promotion Consortium, it's very important to bring wisdoms and cooperate to make 6G happen. And we have to work on the standardization soon. So thank you very much, everyone. Please give a big hands to our distinguished panelists. Thank you very much.
Thank you very much, Professor Nakao and all the panelists. Thank you.